Hi, good morning, everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, we are going to discuss about Thevenin theorem in our lecture series. Let's get into the topic. So, Thevenin theorem is one of the technique which comes under the network theorem. So, most commonly, we use Ohm's law, Kirchhoff's law to solve complex electrical circuits. But we must also be aware that there are many circuit analysis theorem using which we can calculate the current and voltage at any given point in the circuit. Among the various circuit theorems, Thevenin theorem is most commonly used. Thevenin theorem states that it is possible to simplify any linear circuit irrespective of how complex it is to an equivalent circuit with a single voltage source and a series resistance. So you can see this diagram. The left side we have a linear network containing several EMF, that is several voltage source and several resistance is there, but which is converted into a simple one, which consists of one voltage source series with one resistance, and across the A to B terminal we have a RL load resistance. So this is the Thevenin theorem. So if you are given with any complex network, we can simplify this complex network circuit into a simple one, like one voltage source and one resistance. This is the Thevenin theorem. So the Thevenin equivalent circuit is shown in the image. In this image, we can see that the multiple resistive circuit elements are replaced by a single equivalent resistance (RS) and multiple energy sources by an equivalent voltage Vs. So the Vs, the voltage source, which is also called as Vts, that is the Thevenin voltage, and Rs, which is called as a RTh or R equivalent. RTh means the Thevenin resistance, or R equivalent, which is nothing but of equivalent resistance. So let us see an example so that you can understand the Thevenin theorem easily. So here we have one circuit diagram which consists of two voltage sources, namely called as 10 voltages and 20 voltages, and three resistance, that is 10 ohm, 40 ohm, and 20 ohm, and two nodes, that is at A and B. So for this given circuit diagram, we are going to apply the Thevenin theorem. So from the Thevenin theorem, we can able to simplify this complex circuit into a simple circuit which consists of only one voltage source and one series resistance. So how to make the simple circuit by using Thevenin theorem? Let us see. The very first step is to, for the analysis of the given circuit diagram using Thevenin theorem, first remove the load resistance at the center, in the case that is 40 ohm. So in this given circuit diagram, the 40 ohm resistance is a load resistance. So first step, we have to remove the load resistance so that it will be open circuit, right? So remove the second step, remove the voltage sources internal resistance by shorting all the voltage sources connected to the circuit. It is V equal to 0. So V equal to 0 means it is a short circuit. If the current source are present in the circuit, then we have to remove the internal resistance by open circuit. So voltage source means short circuit and the current source means open circuit. This step is done to have an ideal voltage source or an ideal current source for the analysis. Then step 3, find the equivalent resistance. In this example, the equivalent resistance of the circuit is calculated as follows. So we have to remove the load resistance and we have to find out the equivalent resistance. If the resistance are the parallel case, we have to apply the parallel formula. And if it is a series, we have to apply the series formula, right? That means for a parallel series, we already discussed in the previous videos. If R1 and R2 are series, means we have to add R1 plus R2 to find out the equivalent resistance. If R1 and R2, if the both resistance are in the parallel case, then we have to apply the formula R1 R2 by R1 plus R2. This is the method to find out the equivalent resistance for the given circuit diagram. And here in this case, the 20 ohm and the 10 ohm are in the parallel case, parallel connection. So we supposed to apply R1 into R2 by R1 plus R2. That means 20 into 10 by 20 plus 10. That is 6.6 ohm, 6.67 ohm. This is the equivalent resistance for the given circuit diagram. So this is named as RTH. That is the Thevenin resistance. And the next one, finding the equivalent voltage. So for the equivalent voltage, we have to remove the we have to make short circuit. So by using the short circuit, we can find out the value. That is, first we have to find the current value. That the current value is I equal to V by R. So we have value 0.33 amps, and finally we have to find out the um, uh, Thevenin voltage. That is a VTH. The VTH value is 13.33 volt. So finally, the fifth step is to draw the Thevenin equivalent circuit. The Thevenin equivalent circuit consists of a series resistance 6.67 ohm and voltage source of 13.33 volt. So this is the equivalent circuit. So as I said earlier, the equivalent circuit consists of only one voltage source series with one resistance. But in the given circuit diagram, we have three resistance and two voltage sources. That is simplified like this by using the Thevenin theorem. So finding the load current, we can use I equal to V by R formula. So V voltage value we know that, and also current resistance value we know. So from that, the current value is 0.286 amps. This is the load current value. So this is the steps we have to follow to find out the equivalent circuit for the given complex circuit by using Thevenin theorem. Thank you.